So what I want to talk about now are shapes of distributions and different words we might use to describe those shapes. So right over here, let's see, we're talking about Matt's Cafe, and we have different age buckets. So this is a histogram here. And in each bucket, it tells us the number of guests that are in that age bucket. So we don't have any guests that are under the age of 20. We have a reasonable number between 20 and 30. We have a lot of guests at 30 in that bucket between 30 and 40, reasonable number between 40 and 50. And then as we get older, we have fewer and fewer guests. So just when you look at something like this, a distribution like this, something might pop out at you. It kind of looks like, if you were to imagine this were an armadillo, this would be the body of the armadillo. And then what we see to the right kind of looks like the tail of the armadillo. And we actually use those types of words to describe distributions. So this distribution right over here, it looks like it has a tail to the right. It doesn't have a tail to the left. In fact, we have no one under the age of 20. But here, when we have a few people between 60 and 70, even fewer between 70 and 80, even fewer between 80 and 90, and if it kind of keeps going like this is a tail, and it's on the right side. It's a right-tailed distribution. So I'd call this distribution right-tailed. And I'm using Khan Academy exercises because it's a good way to see a lot of examples. And frankly, you should too, because it'll help you test your knowledge. But it's not left-tailed. Left-tailed, we would see a tail going like that. And frankly, if you're left-tailed and right-tailed, you're likely to be approximately symmetrical. Remember, symmetry, you define a line of symmetry, and one type of symmetry is one where if you were both sides of that line of symmetry are kind of mirror images of each other. You could fold over the line of symmetry and they'll roughly meet. And this one does not meet that, because if you were to say, hey, maybe there's a line of symmetry here, and you were trying to fold this over, it wouldn't match up. The two sides would not match up. So I feel good saying that it is right-tailed. So let's see. Retirement of age of each guest. Well, yeah, these names aren't that great, but let's actually see what they're saying. They're saying by age, they're telling us the number of guests. So this is the number of guests at a Logan assisted living. So we have a lot of guests that are between 60 and 70 years old, or reasonable that are between 50 and 60, or 70 or 80. And this distribution actually looks pretty symmetrical. If I were to draw a line of symmetry right down here, right at around an age of, I guess the line would be right at an age of 65, I guess you could say, although this is a bucket for ages 60 to 70, then you could flip it over and it looks pretty symmetrical. Not exactly. This bucket doesn't quite match up to this one, but it's pretty close. These roughly match each other. These roughly match each other. So I feel good about saying it is approximately symmetrical. Now, just to know what these other words mean, skewed to the left or skewed to the right. These actually have fairly technical definitions when you get further in statistics, but I guess easier to process version of them are when you have a left tail, you tend to be when you are left-tailed, you also tend to be skewed to the left, and when you are right-tailed, you tend to be skewed to the right. Another way to think about skewed to the left is that your mean is to the left of your median and mode. That might not make any sense to you. You might just want to go after the tail. If you're left-tailed, you're probably left-skewed. If you're right-tailed, you're probably right-skewed. So let's keep going. Let's see if we can see. Let's actually see another example. So this is interesting. This is not, we're not given a histogram here. We're not given a bar graph. We're given a box and whiskers plot, which is really just telling us the different quartiles. So just to remind ourselves, this tells us the minimum of our data set, the bottom of our range. So the minimum value in our data set, we have at least 111. And then the maximum value of our data set, we have at least 125. Now this line right over here is the median. The middle number is 21. And then the box defines the middle 50% of our numbers. So it's kind of the meat of our distribution. So if we were to try to visualize what this would look like as maybe a histogram, and we don't know for sure because we might have a whole bunch of 11s, not so much that it skews this, but we could have more than one. But a distribution that this could match up with is something that looks like having a tail down here, and then you kind of bump up here. This is the meat of the distribution. It kind of looks something like that. And I can't draw because I'm doing this on the exercises right now. But for something like that, well, something like that would have a tail to the left. Would have a tail to the left. It has its range goes fairly low to the left, but it might not have a lot of values there. If it had more values on the left side, this box would have been shifted over because a larger percentage would have been on the left, so to speak. And so this one, I feel pretty good about saying this is skewed to the left. It's definitely not symmetrical. If it was symmetrical, the median would be pretty close to the center. The box would be pretty centered. And it's not skewed to the right. If it was skewed to the right, you would have a tail to the right. You would have this whisker would likely be much, much, much longer. And we're done.